So we're talking about attacking authentication. You have to somehow authenticate people, know who they are, to limit what they can do, and so there are ways to do it. You can have forms-based authentication, which is by far the most common, where you get a name and a password, and they set it up and they compare it to some stored list on the server. You can have multi-factor SSL certificates or smart cards, which are much more secure than names and passwords, but they're kind of hard to handle. You can't remember them and type them in. You have to store them on your hard drive or carry them around a thumb drive or something, or smart card. HTTP Basic and Digest are the methods that have been around forever to automatically add credentials to web requests. And there's Windows integrated with Microsoft credentials, which is typically used only inside LANs and corporate networks, very rarely used on the internet. And then there are third-party authentication services, of which a lot of them have come, like Microsoft Passport and so on. A bunch of these have been proposed. The only thing that really hit it off was like log in with Twitter, log in with Google, log in with Facebook. Those have turned into the universal authentication services. Pretty much everybody lets you log in with Facebook. That's not what anybody exactly planned, but that's the way it came out. So two-factor authentication, of course, you carry one of these things or some other second factor, and this is, of course, a whole lot more secure than just having a password. You have a password plus some kind of token that comes from your Google Authenticator on your phone, or an SMS message, or a token you're carrying around. Your SSL certificate is just a long cryptographic key, which is essentially impossible to forge and to transmit information from that over the network. This is more expensive to use at a company because you have to distribute these things, harder to replace in the help desk. When people lose their computer, you have to generate a new one and all that jazz, but a lot more secure.
Computers, like there are people always forget their badges, for example.
Right.
Like, what will be the work around the day? Like, how could I access
I know.
my
See,
PC?
you have this problem. Either you have to like make them go home and get it and lose a bunch of hours of work, which means you really care about security, or you have to have some lower security alternative, like a single-use token you give them or something,
okay.
or some kind of backup password. And that's the dirty little secret. Everybody has this secure login, and then they have what do you do when you forget your password, and it's something like your mother's maiden name or something that's pretty easy to get. There's usually like a back door that's pretty much standing wide open. That's why it's all, unless you're really willing to sacrifice a lot of money, there's a back door that's pretty much wide open. That's the problem. So anyway, HTTP Basic, Digest, and Windows Integrated, these are things that automatically put credentials in every request you make. And they've been around for the Basic and Digest, been around for a really long time, and they're easy to use, but not that common on the internet. Microsoft has had their Microsoft Passport, Windows Hello, and various attempts. Microsoft kept thinking it would be swell if everybody is logged in through Microsoft to get to every website. I don't know why they thought so. They must have thought there was money in it or something. But nobody ever cared. They had a series of these things, just like so many Windows products like Silverlight. Microsoft invents something, everyone, Visual Basic, VB script instead of JavaScript. Microsoft invents this junk and promotes it, and everybody says, just shut up, I'm going to keep on using my Android phone. And, there's another flop. Obama decided in 2011 that he did a survey and found out the average person has 18 passwords they're trying to remember, so he announced, like he did, just out of the blue, without talking to anybody, the US government is going to be your authentication provider. The government will run a server, you'll just log into the government website all the time, and it'll be the only password you need. And everyone said, are you out of your mind? That's insane, that's probably unconstitutional, nobody wants to do that. And it just vanished. He said a lot of stupid things, like we're going to go invade Syria on Assad's side to punish the other side for using chemical weapons or something. Like, are you out of your mind? We're not going to do that. He said a lot of this stuff, and then tomorrow just pretended he didn't say it. That's kind of why a lot of the right-wingers got really fed up with Obama. He was prone to just stand up and say stupid things without any apparent vetting first. Not quite the way our current president does, but in his own way, he had some of the same flaws of just spouting out stuff that he'd have to apologize for later. I remember McCain said he was going to put a base on Mars. Everyone's like, what are you talking about? This is why you're supposed to have counselors. You're supposed to have someone stop you before you go in public with these stupid ideas. So anyway, this is what really is out there. You can log in with LinkedIn or Facebook or something. This is what everybody has. In the real world, everybody pretty much uses Facebook and Twitter and Google as their real third-party authentication providers. Those just became popular. So you can have design flaws. If you let people choose passwords, they will typically choose really lame passwords. The most popular password in the world is 123456, and you can get lists of the top 100 or top 1,000 passwords. And if you just try them, a lot of people will use those if they can, because they just hate all this password nonsense and they have something simple and they don't really feel like it matters. So you can look for any description of rules. You can test accounts and see if the rules are actually enforced. Sometimes the rules are enforced by something worthless like client-side JavaScript, so you can actually break them. But then you can just try to register accounts to see what rules are really in place. And you can try to change passwords to various weak values to see what happens, to see what the rules are. Brute force, in the mathematical sense, brute force should be every combination of letters, but colloquially, what people call brute force attacks are really dictionary attacks. You have some list and you try every word in the dictionary. So you get some, the only problem with brute force attacks is if you're doing them over the internet, it's pretty slow. You can only do a certain number of guesses per second. If you use Hydra, it makes multiple threads and it can do hundreds or thousands of guesses per second if the website will let you do it. And so you can actually try on websites that let you might be able to try 1 million guesses eventually. You can't try a billion, but you can try a lot. What you ought to have is lockout rules. Your website ought to notice if someone has 10 attempts within 10 minutes to log in with a bad password and then not let them try anymore. But if they don't, then you can run these tools and try a lot of passwords. So Burp can do it, like many other tools. You can have a series of passwords, and when you get in, it'll find the password that makes it. Here's a comment. It just measures the length of the reply. So these all have 1610 bytes. This has 563 bytes, so it's different. These are all failure. This is success. That's typically how you do it. Just count the number of bytes in the reply. If that doesn't work, you could try the MD5 hash of the reply and just look for anything different. And that'll probably do it. There's a bunch of brute force login challenges I put in my 123 class, and I might have put in this class too, where you can try using Hydra, same tool, and other tools to pack into one of my servers. Just practice, see how they work. Hydra in particular has a sort of ponderous command line because you have to give it some information about how to tell when it got in. If you have basic authentication, then it can tell when it gets in because it has a standard HTTP status code to tell it. But if it's some kind of login page, you actually have to tell it, look on the page for this word. And when you see this word, that means you got in. Or look for this other word, and that word means you didn't get in. So look for a page that doesn't contain that word or something, and you have to put that all in the command line. So it takes a little practice to learn how to set up those command lines correctly. Another thing that might happen is people might have an account lockout feature, but they might implement it stupidly, like they might put the count on the client instead of on the server. So your request might have a parameter called failed logins equal 1. Next time it'll say failed logins equal 2, so all you have to do is set failed logins to always say 1, and it doesn't lock you out. Remember, everything on the server should be on the server, but a lot of developers don't know that, and so they put things on the client and assume when it bounces back to them, it hasn't been modified. This is the fundamental mistake that people keep making, which is responsible for most of the vulnerabilities in this class. Okay, that's a thing that can happen. By the way, another thing that might happen is you might be able to test a password without logging in. There might be some information that's different about an acceptable and failed account. Like one thing that'll come up later, which is really pretty good, is go to the password change form. Now the password change form will say, put in your old password and put in 2 copies of the new password. Often you can send it 2 new passwords that don't match, and before it checks that, it will check the old one and give you an answer saying the old one didn't match. So you can test passwords there while you never log in and you never change anything, and therefore you don't put any records in the log, and there's no thresholding. So you can try your 1 million guesses on that form, and it won't hit the lockout threshold. This is what tends to happen. You find some peripheral form which is not intended to let you log in, and people forget that you can use it to leak out information about the password. So here's an example of the insecure lockout. It's an auth demo. Let's see if I can bring this one up. Got it here, and if I go to say that one. All right. Oh, I got to run my burp. All right. Let's see how this one looks. Okay. Well, I found out how to make the font bigger in burp. So That should make life better, especially for the people trying to view this online or in the YouTube video. So my proxy is running, listening on 127.0.0.1. So if I go here and try again, okay, there's my page. Now there are authentication demos, insecure authentication demos. There we are. So let's try, so Dumbo is locked out. So Grumpy can log in. I can put in a password, but Dumbo can't log in because he used the same password. So if you submit for Dumbo and put in the password of Dumbo, it will say you're locked out because it doesn't like you. But if you look at how that's implemented, go to HTTP history. Here's some posts going to authentication. I think it's the last one that was me logging in as Dumbo. Yep, there's username equal Dumbo, password equal Dumbo. So here it is. And if you look at the request, it's got a parameter called lockout equal 1. So if you look at the previous ones, they had lockout equal 0. So it's kind of obvious how this works. So all you have to do, of course, is send that to the repeater. There's the request that's locked out. Go to parameters and change lockout to 0 and send that in. And now I get a reply, and it's not letting me see the reply, so I have to go back to raw and get rid of that stinking header, except encoding zip. We've talked about this before. That's what's causing Burp not to be able to render the page, so let's get rid of that and send it again. And now I get a page I can render, and it says you logged in as Dumbo. So now I'm not locked out anymore because they put the lockout on the client. So it's just a simple example of it. All right. So that's the game there. All right. You might have verbose failure messages. This is pretty common. So you try to log in, tells you password is incorrect. Here it tells you user is not recognized. Many people do this to help users see where they made a mistake. This is a very bad idea. It turns out to be very fatal. This is what Weave did. AT&T's login for AT&T accounts for iPads using AT&T had this feature. You could put in an email address and it would tell you whether that email was in the system or not. And he was able to get the IMEI number down here too from another part of the form with this vulnerability. So all they had to do was write a script to just try millions and millions of emails and IMEI numbers and match them up, and they were able to find a huge database of millions of IMEI numbers which are supposed to be private. And the reason they are private is because at this time, a lot of mobile applications you'd run on your iPad actually used your IMEI number as the entire authentication. Because it was supposed to be a secret, it was built into your device, so you'd log into like Twitter, it would just look at your IMEI number, know who you are, and not bother you further. So if someone found out your IMEI number, they could totally get right in your accounts. And so Weave said, this is awesome, so they wrote this script, just a bash script that would totally find this stuff, ran it, and dumped out the data to try to humiliate AT&T. And then they tried to prosecute him, and after a lot of struggles, they won to protect him. Because the overzealous prosecutors tried to improve their chance of success by moving the venue to a court in New Jersey instead of wherever it should have been, and that is specifically forbidden by the law. You are not allowed to cherry pick your jurisdiction you prosecute someone in order to get them convicted, and they tried that, and that's how they got him off. And at the time I said that's a technicality, and the EFF wrote a blog saying, that's not a technicality, that's a fundamental right. You can't have people doing that. Yeah, I regard it as technicality because it didn't really get to the issue, which was of interest to most hackers, which is this really a crime or not? But in my mind, actually, that's not the issue because I've been on the other end of people threatening with legal action for this sort of thing and stuff. We've had unencrypted chat logs that came up in court of him talking to other people saying, let's not tell AT&T and let them fix this. Let's dump out 1 million of them and dump it out publicly in the New York Times to hurt them as much as possible because I hate the company. And that right there is conspiracy to hurt a company. And it does not matter technically what he did at all. If you had a talk about throwing bricks through the windows or putting a bomb in the building and planned it to hurt the company, that's another big crime. And the technical part is really the smallest issue here. But anyway, that was the part that got the attention of the hackers. Anyway, so if you can find usernames, this is not a good thing. You would like not to know. This is very common when people dump out, say, databases that only contain usernames, or they contain usernames and passwords that are hashed in a way that people really can't crack them. Then people would like to say it doesn't matter, but it does matter because now you know who to send emails to. And you can also their email address, and you often know their first and last name, so now you can send spam to all those people, and they really will have accounts, and they'll think it's really coming from the company. It's like Comcast started calling me on the phone many times with some kind of broken autocaller, telling me that there's something wrong with the cable, and they wanted to fix come into my house and fix the cable, and I said, I think this is some crook trying to spam me. I put it on Twitter, and they said, that's really us. But they still annoy me with a lot of phone calls, and I never let them in. They think something's wrong with it, but it's working, and I really don't care about their opinion. Anyway, so if you let people go to the website and somehow try a million usernames, especially if there's something obvious like emails, this is not good. And so this happens pretty often. So if you try to log in and you have a bad username, and then you have a good username but a bad password, even if the result looks the same in the browser, it might not be the same. And Burp has a tool called Burp Comparer here. So you can actually compare character by character or byte by byte to see if the response is really the same. And here they found that there's a parameter with a value name here that's different than the value name here. So you can tell whether the username is accepted or not, even if the browser doesn't just make it blatantly obvious like this one does, or where it says, bad username on one side. So let's play with this one. In Hackazon, we can do this. So let's try it. Hackazon is, of course, my favorite demo. I bothered to set up this server. So we got Hackazon. I can log in. So let me clear my burp, go to HTTP history, and delete this stuff. Okay. So now let's go to Hackazon and use a real username. That's a real username, but I'm going to put in a bad password. So that's my first attempt to sign in with a good username and a bad password. And it says username or password are incorrect, which is what it should say. That's not making it as easy just looking here. Now if I put in a bad username and a bad password, maybe the results will be different. So let's sign in for that one. I get the same message here. And so the question is, are those really the same or not? Now I'm upset, why don't I see two of them? This is, okay. Okay, those are the two. I don't know why this looks a little different, but it doesn't really matter. So let's send this to comparer response and send this one to comparer response, because I could compare the requests or the responses, but what I care about is the, what's going on here? Response, okay. Let's go look at the comparer. There we are. So this is one, that's the other, and I want to compare them. So I'll compare them by words, and here we go. And you can see there's a date stamp, and of course that's different. There's a content length, which is a little different, which by itself is pretty interesting, but it's actually not going to be that interesting. If you go down here, it highlights all the differences. And let me see if I can, that's working pretty well. The differences are, there's the difference. The difference is it prints out the username. And of course, I changed the username in one case. So if I go to the same height, there it is. That's why the length is different, and that's why the username is different, but that's not really telling me anything. No. It echoes back to username. So it turns out Hackazon does not have this vulnerability on that part of the page. So, but this is a useful tool in Burp to find it, so you can easily find subtle differences. All right. Other places do, and I think I got a picture. There's no useful differences in Hackazon, but I think the text, this is the textbook showing one where there is a useful difference. So let's try some of these Cahoots. I will run Zoom in case there's someone that wants to connect remotely. Okay, what's the most common form of authentication? Okay, of course it's name and password. Let me see what this chat message is. What did Obama propose for us? You had the Government Authentication Service. All right, what's the defense that most effectively prevents brute force attacks? Okay, a lockout policy where password complexity would sound good, but what really does it is lockout policy so you can't try too many guesses before it stops responding. Of course, correctly implemented, not stupidly like on the client. All right, so what's the side channel that will let you do user enumeration even with identical error pages? And it's timing. Even the same page might take longer to load for a successful login or a successful username and unsuccessful username. And that actually was a big thing in EasyCTF. There was a fun timing puzzle. Anyway, so that's the first one, Patrick. And Matt. Evil Morty will probably have to tell me who they are. That doesn't sound like a real name. And carry on here. So the next thing is you might transmit the credentials in an unwise way, like unencrypted, so people can sniff it from anywhere, on the internet backbone, on your local network, in the wireless coffee house you're sitting in, and just lots of places that the packets are flying through. All right, so of course the eavesdropper can sniff on HTTP trivially if you don't have any encryption. HTTPS can't entirely prevent it. If you send the credentials in a query string, like question mark, name equals name, semicolon, password equals pass, right in the URL, then it will appear in saved internet favorites and in server logs and in proxy logs. Even though it was transmitted with encryption, there will be copies of it in things that might not be encrypted, that might be available. And another thing is, even if you take it in a post, if you have a 302 redirect, it might put it in a query string for the next step and end up in the log. And this is how a lot of companies like Salesforce, is the demonstration I use in 123. Salesforce has an HTTP login page that redirects to HTTPS when you log in. And so you can hijack it at that point. If you put the credentials in a cookie, the credentials may be stored in cookies, which may be sent unencrypted. Even if they are not sent unencrypted, they can be stolen off the wire and perhaps reused without decrypting. Now this would not apply to HTTPS encryption, because HTTPS encryption uses a key and it's different every time you send it. At least with TLS 1.2 it is, because it's forward secrecy, so you can't replay that. But if the cookie is encrypted with some other system and then sent over HTTP, you can steal it. And even though you can't open it and find the password, you can just replay it and get in someone's account, unless they have another parameter to prevent that. And this is the way Google worked with Gmail until about 3 years ago. There was a login page by HTTP, and then you would click the link, and the login button was HTTPS. So the actual login request was HTTPS. This is what Salesforce still does. So a person running a man-in-the-middle attack on your LAN can intercept your Salesforce page and replace it with an HTTP version, and that's what SSL strip does. So your login is over HTTP, and that's why it's a very good thing that soon browsers will just start warning you every time you send anything over HTTP. And then there will be some kind of warning if some client is using SSL strip, because SSL strip is just a proxy that lowers HTTPS to HTTP. And by the way, Burp can do that too. It's one of the options. That's what I used to do to handle secure websites when I didn't want to bother importing the certificate, was just deliver it to my browser over HTTP. Then Burp would turn it into HTTPS, and that way it'd be easy, and then you can sniff it with Wireshark and such. So you can do cross-site scripting, even if things are encrypted. So let's take a look at some of these XSS demos. And I don't even think I need to go through Burp for this, but I might as well. This thing is ready to go. This is the attack page, and I've got some XSS demos on here. Here they are. Okay, so you can put a message, developer was drunk, okay, and it puts that message on some kind of board, like a Facebook wall. But you can also put script tags in there because they didn't filter them out. This is one of the classic ones people do just to detect the vulnerability, is pop up a box. So let me make this bigger. Pop up a box just showing an alert box. So now you get an alert box showing this vulnerability. All right, now, if you, Firefox lets you do this, other ones don't. So here's some more reflected ones. Now here's one that has on click. If you click it, this box pops up. So you can, this one here, when you click it, will pop up a box containing a cookie. And I put a secret value in a cookie so you can see that. This is the real threat. And even if I loaded this page over HTTPS, if you have a cross-site scripting vulnerability, so I can add script tags to something you'll click on, then that can send it with HTTPS to my server where I get it. And that's what this does. I put a script on my server to pick it up. So you can open a pop-up window here that will show something. This is something malware people do a lot. They have a pop-up window or an invisible iframe on your page that loads content from another page to deliver malware. And you can send it to a remote log. That's what this one does. Sends a copy of the cookie up here to a remote server. That's the full cross-site scripting attack that people tend to use. And you can see this if you look at, inspect this. Let me highlight it. Oh, it shows you right there. Sorry, that's right there. That's it. So just on and click, it'll open my server, a PHP thing called here, and it will just add document.cookie in as the text. So it just puts the cookie up on a remote server. And this is how people use cross-site scripting to steal cookies. One of the most famous cases of this was PhoneFactor. PhoneFactor was one of the very first two-factor authentication systems. And it would call your phone with some second number you had to type in to log in. And so the CEO of PhoneFactor offered a $10,000 reward to anybody that could hack into his email. But he said, I'm absolutely unhackable by using two-factor authentication. So professional pen testers got it within like 12 hours because they downloaded it and played with it, and they found out, just like you might think, just like Google two-factor, you don't want to keep on having to answer a phone call every time you log in on your laptop. So there's a box that says, remember this laptop, with like a cookie, so the two-factor doesn't actually happen from your trusted laptop. So they sent him a PDF file as an attachment saying, we've won, this PDF file is the proof. And in the PDF file was a request that sent his cookie to a remote server. So now they had the cookie that made it appear to be his laptop, so they didn't need the phone call, and they got in. And what I thought was cute was the social engineering. They lied and said, we've hacked you, but when he read that document, that made it true. But anyway, that's yeah, that's how it goes, you know. I remember I was reporting vulnerability to some guy. I was talking about this a couple of days ago, and so I sent him an email saying, "Dude, you've got a vulnerability. Click on here, you'll see my page." He said, you're a crook. I'm not clicking a link. I got an email." I said, "Well, you want me to attach a PDF? Would that make you happy? You want me to attach a Word document? How do you get through the day without clicking any links?" It was a problem. He wouldn't believe me enough to read the vuln report. Anyway. So you have to have some way to change passwords. Some websites do not allow you to, which is kind of nuts. Before long, you'll be sorry. Some people for a long time said you should make your users change their password every 30 days or something. There was a report that came out about a year ago where people said, all that does is drive people nuts and not protect you. Because what exactly is the threat? You think that someone writes their password down and somebody steals it, and they're going to wait more than 30 days to use it, so a 30-day change will prevent them from getting in. This is kind of stupid. Anyway, however, users might know when they lose their password that it's time to change it, and they ought to have some way to do it when they want to. So in the password change system, like I was saying before, it will usually tell you if the username is valid. You put in your username, new password, old password, and it'll tell you, that's not recognized username, so you can do username enumeration. You can also often do brute force password attacks on the existing password field because it validates the existing password field, and if it doesn't match, then it bounces you back without looking anywhere else on the form and without having a CAPTCHA, so you can send automated requests, millions of them, and that's one of the many common holes that lets you enumerate things getting past lockout thresholds. So the reason this happens is because the actual decision tree that the programmer has to write is complicated. This is what you have to do. Identify the user somehow, validate the existing password, consider if it's time to lock out the user, then compare the new passwords with each other and against password quality rules, then feed back error conditions to the user, and it is very often the case that some part of this is not done correctly, or in the right order, or wisely. This is a lot to ask a programmer to do. Like 4 or 5 states they have to wander through. If they give you too much information in the error condition, or if they, like a good programmer learns to write efficiently. If you want to test 5 conditions, if the first one is false, you don't test the other 4. You say, well, I figured out to reject you, so if this fails, I just go here and say, try again. It seems like that's just writing efficient code, but it's writing vulnerable code, because now I can enumerate the username or the password that way. That's why this is like timing attacks. Timing attacks are similar. You check the username, then you check the password. That means if the username is bad, the response comes quicker than if the password is bad. That's the one that was in that Kahoot. So the programmers who have been trained rigorously to always be efficient are creating vulnerabilities without realizing it. So the forgotten password functionality, like someone brought up earlier, is absolutely the weakest link. When your users show up at work without their password, then you have to have some other way to get in, and this is usually much, much weaker. So plenty of people got hacked like Sarah Palin did here. Because if you have like a Yahoo or an AOL account, then they don't have any money to pay a real help desk person, so they have some kind of automated system with some lame question. And that's the game. And you can often brute force it. Sometimes they even ask questions like, what's your favorite color, where there's really only a small number of guesses. You can guess them all. Sarah Palin's account got hacked because they asked, what city did you meet your husband in? And they just went to like her Facebook page and found out what high school she went to and said it's probably there, and that was it. So if you let users write their own questions, they'll often write really foolish questions, like yes/no questions and things like that. If you let them put a password hint in, they will often just put a copy of their password or something very obvious in there. This happened when there's a big breach about 3 years ago, and they leaked out the password hints. And the password hints were mostly just equal to the password. So the password was hashed in a way that was hard to crack, but you didn't have to. The hints itself were enough. That was one of the really big breaches. It might have been LinkedIn or something. And often the mechanism used to reset the password is vulnerable. You might disclose the forgotten password to the user. This is the way a lot of people write them. So if you forget the password, you answer the challenge question, and it tells you your password. And I was told by people who worked at Yahoo, or who knew people who worked at Yahoo, that Yahoo tech support customer support can see your password on the screen. Because people would call Yahoo and say, I forgot my password. I think it was like Poodle 1975, and then there was a letter, but I forgot that. And they'll say, okay, that's close enough. Here's what it is. That's what a lot of people do. This is a terrible idea. That means they have the plain text password on the server where it can be stolen. It means people can see it. So you could just bribe somebody to tell you someone's password, which is pretty bad. Another thing they do is they often just let you in the account after you make a challenge. I was making an account on, I think, Moodle. The Moodle that I'm using for my other courses, the free Moodle for students. And I made a new account, and it let me in without even choosing a password. Creating an account with an email address was enough to be logged in as that person. I just wouldn't be able to log in again later without going to the email and finishing the process, but I was in. And so this tends to happen. All right. Some people will let you specify the email at this point, so I can go into login as Sam Bound, and I can say, oh, send the password reset to Joe Green, because I get another chance to change that email. So this is just a wide open door to get in somebody else's account. Or they feed it from something like a hidden field or a cookie, which they think I can't change, but of course I can. All right. This is why whenever you do a password reset, you should get an email telling you somebody reset your password. So if somebody else did it, you have some chance to know that. And I know Google services are quite good and Cloudflare is quite good. I'm always getting messages. If I travel to a coffee house and log in, it'll tell me a login came in from an unexpected IP address, which is pretty nice. I appreciate that information. There's a Remember Me function where you can click on something and then it won't ask you for your password again later. You can implement this various ways, but the most common thing is just put a cookie on your machine that has a long password, a long lifetime, which is all right, but the cookie might have predictable data, like just a session number in it, so you can figure it out. And what's worse, of course, is most logout buttons do nothing. They just delete the cookie in the browser, so you have to log in again, but it's still on the server, so if the person who stole your cookie can just keep reusing it, and that's true of a lot of services. All right. And if your user ID or session token is encrypted, remember you can still be stolen by cross-site scripting or by just stealing your phone and going in the file system, unless your phone is encrypted, like iPhones are and Androids usually are not. You can impersonate people. This is a natural function. Your help desk, for example, has to have some way of helping people. Now, it's the right way to help people, of course, is I can click a button and that will send you a password reset email to your account on file, and you click that and choose a new password. But other people write systems where the person at the help desk can actually go into your account and do something. Our previous system, before Canvas, we had Moodle, and I could go in, on I think a Cisco network, I could go in and change students' passwords. If they forgot their password, I could go in their account and change their password. Which, you know, that's a similar thing. I'm impersonating them. And that the question is, how is that implemented? The administrator can now get in your account. So one simple way is there's just a hidden backdoor password that works everywhere. And there's a whole chain of products that are shipped this way with a secret master password, like a master key, which is okay until somebody finds out, and now suddenly they're all insecure. There might also be some hidden function like impersonate user.jsp, and that function might not be properly secured, like requiring some credential that only the administrator has. So here's incomplete validation. You may remember Windows 98. Windows 98, you could log in, and all you had to do was get the first 8 characters right of the password. You could put anything after that, and it didn't matter. And Microsoft Hotmail was that way for a while. If you've been using a password that has more than 16 characters, just enter the first 16. Everything else is being truncated silently. This kind of thing happens a lot. There are also a lot of password fields that have a maximum length that's short, like 12 characters, and won't let you use spaces and apostrophes and stuff. Those are terrible ideas. If they were hashing the password, it wouldn't matter how long it was, and it wouldn't matter what crazy characters it has, and that would be a lot more secure. So another thing people are doing lately is they're blocking copy and paste, so you can't use a password manager on phones. People are getting pretty sore about that. Anyway, another issue is non-unique usernames. This is really kind of nuts. This happened when I tried to book a cruise to Alaska. I went on their website a couple weeks ago to book a cruise. I put in my email address and my name, and it said, you have to call tech support. It turned out my father, who died 10 years ago, had made an account. And ended up with an account that had my name, my sister's phone number, and my father's name, my sister's phone number, and my password. That's what they created out of this mess. So I kind of think, anyway, you might be able to create an account with the same username as an existing account, and of course, that's madness. And then you'll be able to leak over to the other account. The most widespread case of this I know of is Bitcoin Cash. Bitcoin forked and Ethereum forked. There came a time when they modified something and not all the miners agreed, so there are 2 versions of Bitcoin. And what that means is, up to a certain date, the 2 coins were identical. After that, they diverge. So everybody now has coins on both chains, and if you go to an exchange that doesn't know this, you can spend the coins from one exchange at the value of the other one. And the prices are wildly different. Like Bitcoin Cash is worth $4, Bitcoin Main is worth 4,000. But they're mathematically identical numbers up to a certain point. So that is a similar issue where you can confuse systems and get away with something you shouldn't get away with. Sometimes they automatically generate your usernames like this, and then of course you can predict what other people's usernames are, which is not good, because that's a big step towards breaking into their account. And a lot of people use default passwords, the same for everybody making a new account. And so I know the college, I think they still do, they use your birthday for your online login. And one student years ago in hacking class reported this to vulnerability. He said, you know, I can just look at somebody, figure out how old they are. There's not that many chances for their birthday. You could pretty much break into somebody's account that way, and you probably could.
You just friend them on Facebook, and Facebook has your birthday.
That's right. I mean, your birthday is not very secret at all. Even your mother's maiden name would be more secret. You could argue that's a pretty miserable system.
Yeah.
It seems like it'd be a lot better to just put a random number and email it to you or something. Would be better than that.
Movie stars have the same thing. There's a movie star website. Their birth date is on there too.
Yes. And another thing, which is what got the world of the news in World of Trouble, is everybody had email voice boxes, and the default password is the last 4 digits of your phone number. So you can get in anybody's email box, and anybody's phone mail box. And people were doing that all along. Ended up in a world of trouble over that. Then you can distribute these things insecurely, like what I just said. If you're emailing a password to somebody or sending it by SMS, this is of course risky because it can be intercepted at the other end. Users may well never change it. Your activation or password reset URL might be predictable, and so on. You really shouldn't be emailing passwords to users. You should be emailing like password reset links where they choose a password, and the password should be stored only in a hashed form on the server. But a lot of people haven't got the memo. There are various online websites that are like halls of shame to pick on people who are sending passwords around in plain text proving that they're storing them insecurely. And we're up to B. All right. Let's see. No more chat messages. But people have vanished. Who knows? I don't know if it's working too well online or not, but anyway, it's working in the
7
classroom.
digits.
Yeah, it's getting longer. 7 digits now. I think I have seen 8. So I guess Kahoot is popular.
Actually, XP activation can use your cell phone now, of course.
For XP.
Yep. If you activate XP and don't copy a legitimate license, they'll use your cell phone as process to activate XP.
I'm surprised you can even activate XP anymore. XP is over, man.
They want to play Mahjong.
XP hit its end of life like 4 years ago.
No, I know someone that wants to play Mahjong. It works on XP.
But I thought the activation servers would be down or something.
It's up. You can still activate XP.
All right.
I don't know what they do with your cell phone data though.
Well, Lauren only knows, probably not much. That's the whole thing about Microsoft. Everyone got mad at Windows 8 spying on you. They said, look, we don't sell ads, so we don't really use that stuff. Google would totally store it and use it, but Microsoft probably doesn't really do much with it. But who knows? Maybe they'll expand into advertising.
They'll sell it to somebody.
Let's not Google.
They might. They certainly love to march into a business that's owned by someone else and be almost as good and whine about why it didn't work. That's it, ready here. All right. So, if you use HTTPS, what will you prevent? Eavesdropping. Just sniffing the network won't work anymore, but the rest of those things will work. So what functionality can you implement with just a persistent cookie? Yep, that's how Remember Me typically works. All right, what item is insecure because it doesn't validate the fields in the correct order. So that's password change, has all those fields and a complicated logic, and it is often the case that doesn't go through all the steps in the right order and creates various vulnerabilities. So which functionality would you implement with a backdoor password that works for every account? Anyway, this is user impersonation. What's that?
Who said that there was a backdoor?
Oh, some student said it and claimed he'd seen it, but I really don't think so. But you can never prove it.
They put it there on purpose, right? They plant backdoors on purpose, the developers?
Yes, but they're supposed to remove it before they ship the product, and sometimes they don't.
That's the one that bit Apple recently with the root.
Yeah.
Yeah.
It just didn't check.
Yeah.
You could put anything in. It wasn't a backdoor. But there was also, it's commonly done through help desk and stuff, so they can get in. A lot of products are shipped that way. There's a secret password so they can get in. Because people forget their password, and then they call the help
I thought
desk.
there was an iOS attack that locks you out of your front browser or something for the phone or something. It was on the radio or something on CNIT.
I know there were a bunch of them that
11 point something 3.
failed to check your password. Anyway, I see it's at the hour. Let's take a 10-minute break till 7:10, and then we'll do the last section of this. All right, let's talk about some flaws in implementation. This one is good, clean fun. You can have a fail open login, where if you crash the login, it will let you in. And there are various ways to implement this, but if you put an invalid username, like one thing that works sometimes is open and close square brackets, so the username is not a string anymore, now it's an array or something. And when there's an if statement that says if username equals something, it will not equal because it's a different variable type, and it will fail, and sometimes when it fails, you get in, because of the way they write the code, where when the comparison fails and you get an error message, it passes. So that's what they call fail open. If you somehow put in something unexpected that causes it to be unable to do the calculation, you'll get in. Multi-stage login. We talked about how two-factor should be more secure. And in principle it would be, but it's also more complicated. So now you have several stages. Put in your username, put in your password, put in your token, or your thumbprint or something. And so now that you're putting in these things, this might be one very common mistake is there are several pages in a row And so the first page asks for your username, next name asks for your password, next name asks for the PIN, but it doesn't remember your username and password. Instead, it's getting them from a client. So I can answer the first two questions for me, then go to the PIN and answer with a different PIN and change the username and password in the request. And it will think I already passed the password test because it's on the third page. That's the kind of problem here. The developer will assume that you do these pages in order, but you don't have to do them in order. You can do them in a different order. You can change data from one to the next and so on and trick them. So another thing is if you use a randomly chosen question to verify the user, and you have like 10 possible questions, I might be able to specify which question I'm answering in the request so I can change it to a different question that's easier to answer. And so on. Or you might allow many requests, so I can just keep trying until I get a different question that's easier to answer. Then they're storing the password. The password has to be stored somewhere on the server. The user is logging in, somehow you're sending the password up, it has to somehow recognize a valid password. And therefore, there is some kind of file on the server that contains password information, and that is a high-value target. So, what people do is sometimes they store it in plain text, which is really dangerous, or sometimes they hash it with a simple hashing routine like MD5 or SHA-1, which is really almost as dangerous because MD5 and SHA-1 are not intended to protect passwords. The purpose of them is to authenticate data, and they are designed to be very, very fast. So if you download a movie and it's 600 megabytes, you can calculate the MD5 and it doesn't take an hour. It takes about 30 seconds because it's doing a very simple, very fast mathematical calculation on the bits, which means passwords, which are short, hash in like 1/1,000,000th of a second with MD5 or SHA-1, which means I can try a million guesses per second with the CPU, which is just what you don't want for a password. So they are not appropriate for password hashing, but a large number of people think they are because they are unaware that there are better ways to use hash functions, and they think they're the only hash functions that exist. So when you're securing authentication, the fundamental rule occurs here. This is the classic thing of security. There's confidentiality, integrity, and availability, and if you get more of one, you have less of the others. So if you have more confidentiality, by having more authentication, security, you have less availability. Now there are going to be more problems. So your users are going to have to go through a more inconvenient login process. More of them are going to fail and be going to your help desk and so on. It's going to be less convenient if you make it more confidential, more secure, and that's just fundamentally the issue. It's going to cost you more money to be more secure, so you have to make a balance. How much security do you really feel like paying for? So minimum password length, alphabetical, complexity rules, avoiding dictionary rules, unique usernames, automatically generated usernames or passwords, letting people use long passwords, and these are all good. These are good recommendations for strong credentials if you're going to use names and passwords. Names and passwords, like we said before, are the most common technique because they are the easiest and cheapest to implement. It's also the weakest technique. So when you create credentials, you have to protect them. When you send them over a network, you have to protect them. And when you store them, you got to protect them. So you got to use cryptography. Don't invent your own cryptography. Use standard crypto. This is the best thing you can do is use HTTPS, by the way, not SSL, but TLS, but in the spirit of slang, people still call it SSL, although all versions of SSL are now deprecated and considered unsafe, and what we're actually using is TLS. Your whole page should be HTTPS, not just the login button, because you want to make sure that they're talking to the right site when they log in. Use post instead of get, because parameters in the get URL are stored in foolish places like internet favorites in your browser and log files on the server, which are not safe. So you don't put parameters in there. And don't put credentials in a cookie where they can be stolen, because cookies are also stored in plain text and often transmitted insecurely. So don't send credentials back to the client because they don't need an extra copy of them flying around the network. On the server, they should be hashed with a proper password hash function, which is not the same. It's just MD5 and SHA-1. There are several different password hashing functions, and there has been a contest running for several years at PasswordsCon, which merged with B-Sides Las Vegas. It's very interesting. A bunch of European mathematicians have spent like the last 6 years coming up with new password hashing functions. And they have a bunch of fancy ones that sound awesome, but nobody's using them yet. What they are using is many rounds, salting and stretching. You add some random characters to the password before hashing it, so if two people choose the same password, that is not obvious. And then you just stretch it, which means you don't just do one round of SHA, you do 5,000 rounds of SHA.
Jeez.
All that does is waste time. And the point is, the user logs in, and you try to make it so it takes like 150 or 100 milliseconds to do a password hashing. So they send in the password, you spend 50 milliseconds calculating, then you compare it to what you've stored, you can recognize the correct password. But an attacker who's trying to guess the password has a dictionary of like 1 million passwords, and now they have to spend 1/10 of a second calculating each one, so they can no longer try 1 million passwords in any reasonable amount of time. Now they can only try maybe 1,000 passwords, and so all you have to do, your dog's name plus your date of birth is good enough, because you just have to not be in the top 1,000 passwords. If you use MD5, you can easily try 100 million guesses in a reasonable amount of time on a normal computer, and that's much harder to choose a password that's not in the top 100 million passwords. That's asking a lot. The default in Linux, for example, this is Kali Linux, and the default method is to use SHA-5, 12, and 5,000 rounds. And it uses an 8-character random salt. That is a secure password hashing routine. Macs do the same thing. Windows, Microsoft is ridiculous. They use 1 round of MD4 with no salt because they designed the system for Windows NT in 1994 before MD5 existed. That was the only hash algorithm that existed at that time, and they never updated it. They're 25 years behind the times. The problem was solved in 1975 by the Linux crypt function, but Microsoft still has not gotten the memo. Anyway, your remember me functionality should just remember something non-secret like your username, or better, just some random number that means something only to your server. If you let people store passwords locally, they should be encrypted with a key that's only on the server. Just encrypt them with a public key, and the private key is on your server. This is excellent advice. I've never seen anybody do this, and I've analyzed hundreds of Android apps and how they store passwords locally, and none of them do this. It is amazing. It's like the entire community of Android developers has never learned that there is something called public key encryption. The cake, I think, was a financial app I looked at. Maybe it was a retail app. They actually used the Android credential store, which is secure, and then put your password with custom encryption that was wrong. They used it for something else, but not for your password. Anyway, cross-site scripting is another issue. You should get rid of it, although it is the most common vulnerability of all, and something like 70% of web applications have cross-site scripting vulnerabilities. And if you tell companies, they don't care and they won't even patch it. It is considered a low risk to them, but you can totally steal someone's credentials with cross-site scripting and get in, unless they put in anti-CSRF tokens to prevent it. So that if I steal your cookie and replay it from another machine at a different time, it will notice that that's not okay. It's also got some other thing to pair with it to recognize that that cookie is being reused by a different person. This is the standard recommendation. You'll find it in your book. This is what everybody said until about a year ago. Force users to change their password every 30 or 90 days. Modern thinking done by some kind of scientific research is that this is pretty much a stupid idea and actually doesn't help you. But anyway, that is what everybody told you to do. It was commonly accepted wisdom until a year or two ago. You can send your credentials in the most secure way possible, and they should be time limited. You should get some kind of registration link that's only good for a certain number of time. And it's a good idea to use something more than just typing in passwords, like a drop-down list. I don't know anybody that does this, but if you did that, that would stop keyloggers, because they won't get the mouse movements also, although some keyloggers, the smarter keyloggers, do get mouse movements.
Can you fool the keylogger if you use a virtual keyboard? So you use the mouse to install a virtual keyboard that's software, so use the mouse to click that virtual keyboard.
Yes, and using the accessibility option for the on-screen keyboard often works. And there is software you can put on Windows machines called anti-keylogger software that scrambles it. And when in the hacking lab, when Ben put those Python keyloggers everywhere, I tried it and it works.
Oh.
It does, I don't know quite what it does, but it scrambles the internal transmission of the keyboard signals in the Windows operating system so the keylogger doesn't get it anymore. So that was pretty cool. All right, so then you validate the whole credential, of course. You don't just take the first number of letters, you're case sensitive. If you get any kind of weird thing about the input, you terminate the session. So if somebody is trying to change other parameters to become the administrator or something. You don't take data that has weird stuff in it, throw out the weird stuff and use it. That's helping the attacker. If it's messed up, it's not a legitimate user coming in through your login form. It's somebody sending a messed up request, and you should just terminate the session. That would be a whole lot wiser than trying to fix it. That's why the whole logic of people that clean input and then use it is wrong. Wait, how did anybody send me malformed input? They didn't use my form, so why are you continuing to process this data at all? You should just kick this guy out. They're a hacker. Anyway, check your code and control user impersonation if you use it. You want to make sure that you're not using it insecurely. If you have a multi-stage login, you need to have all the information on the server, which says, I got the username, I got the password, and now I'm processing the fingerprint. And I know who they are, so if they send me the fingerprint, but it's applying to a different user or a different session, I won't fall for that, because that information is stored in the state on the server. That's the idea. Nothing should be sent more than once by the user, or if it is, it should not be trusted. It should be verified again on the server. So the first task should be to verify that all prior stages have been completed. So if someone is on page 3 of your login, your first step is to make sure that they actually did complete stage 1 and page 2, and they didn't just jump directly to page 3, which many developers will forget to think about. You always proceed through all stages. If stage 1 fails, you don't stop and tell them, because now they got a enumeration vulnerability. You make them go through all the steps, even though they're going to fail. Then you give them a generic message at the end saying you failed, so they don't know what part failed. This at first seems like sadism, just irritating your users, but it is reasonable security, because that helps you give the user, oh, your username's wrong, is helping the attacker too much. So use the same code so you produce exactly the same error message, and hopefully in the same amount of processing time for every mistake. Otherwise, you will be leaking information about what part of it failed. Account lockout can be used for username enumeration. If I try many guesses with an account that doesn't exist and I don't get locked out, I've just proven that account doesn't exist. If I try 10 guesses and get locked out, that proves the username is valid. So again, people often don't think of this. There are subtleties that let you find out valid usernames from invalid usernames.
Can't you just disable it from midnight to 5 a.m., the account?
That's another option, yes, and a lot of people do at companies. And that will stop some attackers. Yep. And then there's self-registration. If you let users choose their usernames, then they can try usernames, and you'll have to tell them if that username is already in use. So now they can do username enumeration. So other ways are to generate names to make them use that, or just use email addresses. This is what most people do. You have to use an email address, and it has to send you an email, and you have to prove you're getting that email in order to get in. That's a pretty good arrangement. All right. So at all these things that take in your authentication, like password change, recover lost password, and login, all these things you can try brute force attacks. So if you use unpredictable usernames and prevent enumeration here, then they have to guess usernames and passwords, and that is enormously more difficult than guessing passwords once you have the username. For the same reason, two-factor authentication is much more secure, because guessing 2 random things is much, much more difficult than guessing 1 random thing. Most people will lock you out for some period of time after a certain number of logins. High security things like banks will disable it completely and make you go to the help desk or go to the bank in person, which is a very good idea. After a certain number of failed logins, something bad is happening. All right.
Actually, there's another part to the banking thing.
Yeah.
I think once a year by federal law, they're required to validate that your status of employment, if you're a citizen or something. I got a screen from B of A saying, we need to validate you to make sure your status and your social security number is still valid, or it's you.
I've never had to do that.
Yeah,
So
it came up.
It must only be suspicious people like you.
Sure. No, what you do is if you do an inadequate transaction at one bank saying, I want to get some cash at Citibank, and they'll fill out a paperwork saying, what's your status?
You
If
know-
they do it improperly, that triggers one to the other bank.
Yeah. Many years ago, I had like $500 in cash I wanted to deposit. I didn't have a deposit slip, and I took a piece of brown paper bag and wrapped it around it and slipped it over the door of the bank. And they called me, well, what the hell is going on here? Which is the thing to do, right? If you get some weird thing like, what's going on? Who is this guy? What account is this for? Anyway, All right, so if you use many usernames with the same password, this is another way to go. If they lock you out for passwords, just use password and try a million usernames. Some clown will have used password, and now it won't lock you out because it doesn't think of counting that way. Now, logically, if I'm trying 10 different usernames from the same IP address within 1 minute, it should be locking me out. I'm obviously a criminal, but it doesn't know that. Anyway, another thing is CAPTCHAs. Put these things in for every login, and now I can't easily write a script that will try many passwords. All the CAPTCHAs have been broken, and you can get services that will let you in, and you can go to Mechanical Turk, and there are people who will solve CAPTCHAs for like 1 cent each, but it is much more hassle than not having a CAPTCHA. It does slow people down.
It's only for human validation. When you
That's
go
right.
to some, like Sonic, for example, you put in a post to make sure you're a person.
It's a very
So
good
that-
idea.
yeah.
And I know something I see smarter sites do like Google is they only put the CAPTCHA after you do like a couple of mistakes. After they get suspicious, then they start putting in the CAPTCHA.
No, they got it different now. They have to choose where's the car or where's the plane.
Yeah, that
You
one I
have to
really
pick those
hate.
bu- yeah.
It says
Yeah,
choose
which
all the
ones?
pictures with signs, and I can never do it.
What?
Like
What's
there's
wrong
just
with
a corner
that?
of a sign, there's a corner of a sign or something, and I can't tell.
Are you-
I'll
oh,
fail. That thing's very annoying. I'll fail it like 4 times. I'm apparently not a human.
you need an
Training the
iPad
algorithm.
and a magnifying glass, sure.
I tried zooming in, and
No,
it just makes me
magnifying
more
glass.
confused. I really don't know what the right answer is. It's like a multiple choice test that irritates you. The answer is not clear, even if you understand it. The question is poorly phrased. You people probably have some of that in my class. Anyway, so
Who's 6?
anyway, so you often have no way to change the username. So the password change form is tough. They have to get the old password. They have to get the new password twice. You have to give them the same message for all failures so they can't enumerate things. And you have to notify the user after this is over, out of band, by their stored email address so they know if somebody else managed to change their password, which is possible, if not likely. And then you have account recovery. What do you do if you lost your password? This is usually a big gaping hole. Password hints are very dangerous. Emailing them, once they enter some proving question, which is, of course, a weak spot, then you should just send them a time-limited, unguessable, random URL to click. I think it was Facebook or Instagram about 6 months ago. The password reset email had a random number in it, and that same random number was used like in that URL to a picture, so you could find that number
Oh.
and predict what was going to be sent to people and get in their accounts. This is the problem when you have a large development environment. Some developer needs a random number. He says, oh, here's a random number, I'll just use that one, without realizing that's used for something like password resets, which is critical. Anyway, are your challenge questions?
That is not random.
That's right. Well, nothing's ever random on a computer, and that means all cryptography is kind of fouled up. All cryptography requires random numbers, and yet there's no real way to get them. So you use things that are kind of random, but not really random, and often you're in trouble.
Generators.
Random number generators, you do the best you can, but they're never that good. This is why Intel responded by putting a hardware random number generator in, I think, the modern Intel chips, ever since the i7. It has a machine language instruction that will fetch a random number from a hardware random number generator. But when that came out was the same time scandals about the NSA came out, so a bunch of people refused to use it, assuming that they probably backdoored it for the NSA. And you can't prove they didn't. So they attempted to address this problem, but somehow a bunch of people still don't trust it. Life is tough. Once you have the NSA in your threat model, you've entered the world of madness. I mean, there's nothing you can do that will stop the NSA. All you can do is go crazy trying. I mean, they're the smartest people in the world with infinite resources. If they want to get in, they're getting in. Just get used to it.
You can just make it harder. You have 4 virtual hard drives,
Yeah.
and then they have to guess where your critical file is.
You can irritate them. but
Yeah,
you can't
you just-
stop them.
yeah.
Yeah. It's like, if a cop wanted to come in here and shoot me, I'd be dead, right? There's nothing I can do. They can totally walk in the door anytime. I just accept that. There's a chance that will happen. That's just a calculated risk. Rather than hiding under my bed, I accept that risk. Google knows everything. The NSA knows everything. That's just the way it is. Anyway.
Bigger chance that somebody, a 17-year-old with an AR-15 will do that.
Well, that's why currently we're having a debate about maybe really ought to stop the 17-year-olds from having AR-15s. I kind of accept the NSA and the cops having those weapons, but maybe not
No,
every
no, now
student
they
in
want to
college,
give
no
guns
matter how
to
crazy.
teachers. No, guns to teachers.
I went down to Texas to teach classes. I do it quite a lot. And I remember when they had a big argument that students are not allowed to take guns into the classroom in Texas, concealed weapons. I said, well, maybe I should change my quizzes. Anyway,
So I go to a grocery store in Phoenix.
yeah,
They
yeah.
walk around with the holsters and
Yeah, that's right.
what?
Anyway, I said, don't let people write their own questions and ask stupid questions with obvious answers. And you should be logging authentication events so you can tell if people are doing goofy things in the login. That would be a good idea. And that's why I put in this class, I put in the Linux machine and put in Tripwire. Tripwire is one of the handy tools to detect intrusions. And it's not the kind of thing, it's in your book only refers to it indirectly. They keep saying log stuff, but this is one of the many security tools you do to monitor if somebody is getting ready to murder on your server. Anyway, notify users when something bad, when you do an account event, and notify them of other events. You'll see that Google does this now. It'll tell you when. You can look up the last 10 people that logged in and where they were. So I can tell if some clown in China has got in my account and they're using it, at least you can tell it's happening. Unless they can delete the logs. So you try to store them someplace where they can't easily be deleted. Anyway, there's around to the last cahoots, and then I'll just clean up and go to the lab to see if anybody wants help on a project. So which one lets you log in with an invalid or blank username? Yeah, Mustafa was there last Saturday, a week ago, 2 weeks ago Saturday. We found 2 ways to get into the science building after it's locked. And this is fail open login. All right, how should credentials be stored? Yeah, that's good. Proper hashing systems. All right, what happens if you fail the first stage in a multi-stage login? Okay, you should complete the process, waste their time, and give them an unhelpful message. That is the secure thing to do. All right, what function should use auto-generated usernames to prevent enumeration? Self-registration. You use an auto-generated username, they do not get to try a bunch of usernames. So Patrick is 3, John E is